slope is m. We always use that letter m. We're going to continue to use that throughout this rest of this week. Does anyone remember what does slope tell us on a graph? It tells us rise over run. That's how we find slope. But what does rising and running really tell us? Good, direction. So it describes the direction. I did not leave enough space there. Pretend that there's enough space to write that word, direction. And it tells us the steepness of a line. So when we talk about steepness, remember we're talking about like how quick it rises or if it's pretty flat. Okay. So if we have like a slope of 1/4, if it's only going up 1 and running 4, is that going to be pretty steep or pretty flat? Flat, yeah. If I have a point and it goes up 1 over 4, that line is pretty flat. It would be easy if I was going to hike up that line. It would be a pretty easy hike. But what if it rose 7 and ran 2? 7 over 2. What would that look like? 1, 2, 3, 4, 5, 6, 7 over 2. Is that a mountain you would want to climb?
No.
No, that was a really bad line. That was bad. Thanks, everyone. Oh, that line was so straight. It was. All right. So, steepness and direction. So let's talk about that direction first. Direction, when we read a line, we read it like the English language. We read it left to right. If you need to draw an arrow to find yourself left to right. All right, so we have different directions of a slope. If I go left to right, if it's rising, left to right, it's going kind of up. What kind of number will my slope be if it's going up? Positive number. Okay. What if it's going straight across? It's not going up, it's not going down. It's a horizontal line. You need to write that there, horizontal. That's the name of the line type. But what's our slope going to be? What's our change when it goes left to right? What's our steepness? Is it going up or down? No, it's going straight across. So is it going up or down? No. So it's moving, but there's no change. So what kind of slope was that? Zero. That slope was 0. That's all right. Sometimes we forget things. So what would a negative slope look like? Down. As I start left to right, we're going to start at the top and work our way down. That would be negative. All right. What's our last type of line that we haven't done yet? A straight up and down. Does anyone remember what do we call that when it's a straight up and down line? Vertical. It's a vertical line. That's the name of the line. How is it moving from left to right? It's not. There is no left. There is no right. It's going up and down. So if I can't move from left to right, can I do slope? No, because slope is left to right. There's no slope here. So if we can't do it, we call that undefined. A lot of people want to put that extra I in there. Just undefined. We cannot define that slope. Alright, so we're going to pause there. Alright, so rise over run. Rise means to go what direction? Up and down. Run means to go in which direction? Good, side to side. No, I think I'm just really loud. Tell her I got the hint.
Okay.
Alright, rise over run. So when we go on a graph, rise over run, we need to start from one point and go to the other point. So as I look at AB, if I count my rise and my run from A to B, my rise, I want to start at A and I'm going to go up. And then my B, I go over. So if we're looking at the line AB, so remember we do that line above it, when we're going from A to B, it goes through. So if I do my rise over my run, my rise, I'm counting how many jumps up we're going. So if you need to count, think about it as jumps. 1, 2, 3, 4, 5, 6, 7. 7 jumps. If you need to put those little bunny jumps in, you can. If that is something you feel like you got 7 without doing that, don't do it. It's fine. So 7 is our rise. What is our run? 3. Goes over 1, 2, 3. So our slope of this first line is 7 over 3, 7/3. Okay, so big thing when we do our rise and our run is we have to go straight up or straight down. We're always rising completely vertical, and then we're running completely horizontal. We're never counting as the diagonal because we can't really count. If I try to count diagonally here, it's is that a half? Is that 3/4? Is it a 2/3? We can't count as we go up the line this way. So it's always straight up, straight over. Because that we can count easily. Alright, let's move to this one. We're going to do LK. Line LK on this one. So again, we're going to do our rise over our run. What do you notice about line LK right away without having to even count anything? Good, it's going down. So what type of number are we going to have? Negative, good. So it's your choice on how you want to think about your rise and run. Some people like to start at K and go up and then go to the left. I like to just always start on the left and go right, because that's the way my brain was always taught, is left to right. And then that helps me think if it's negative or positive, because now am I going to go up or down? Down 1. And over how many? 3. So negative 1/3. coming back to us? Getting flashbacks from 9th grade? Yeah? Billy's having an urge to, like, just shout out in the middle of class? Yeah. You're getting, like, flashbacks to your 9th grade year, and you would just shout random things in class? What? Mubarak's like, I want to stand up and run around this classroom right now. Right? Just kidding. Alright, so what you're going to do now is as a table, you're going to go back to your worksheet, but a worksheet looks a little goofy on this one. Alright, and so when I draw a parallel line through point C, I want my parallel line to still have the same slope. Because that's going to maintain that I'm doing it at the same speed, the same pace. So what does my slope of a parallel line need to be for this first one? What was my slope of AB? Seven over 3. So my slope of my new line still needs to be 7 over 3. So I'm going to start at C here, and we're going to go up 7. 1, 2, 3, 4, 5, 6, 7. And we're going to go over 1, 2, 3. Put a point there. So again, I went up 7 from that point. Put your pencil on C. Put your pencil on C. We go straight up 1, 2, 3, 4, 5, 6, 7. And then we go over 1, 2, 3. And we put a point there. Then if you have that ruler, if you want to just try and freehand it, I wouldn't recommend it. It's going to look a little goofy. But then go ahead and draw that line through those points. Okay, and that's going to guarantee that every time that line goes up, it stays the same distance over. That if we have that same slope every time. So at the bottom of this page, where it says parallel lines have blank slopes. What do we know about parallel lines? What kind of slopes do they have? Equal or same slopes. So on the bottom there where it says parallel lines, I did that in blue. Parallel lines have same slopes or equal slopes. That's going to guarantee that they're staying the same distance apart the whole time that they're running. Now on the next one we have perpendicular. We haven't talked about that word perpendicular in a while. What does perpendicular mean? That's parallels are right next to each other. Perpendicular means they cross, and exactly at what degree do they cross? 90 degrees. So perpendicular, remember, is 90 degrees. And in order to get 90 degrees, we're going to have to go the other direction. So this current line here, LK, is a negative slope. If I want to get it to be 90 degrees, is there any way I can make it still negative and be 90 degrees? I have to like flip it. And I have to go the other direction. So it's going to go from negative to positive. And kind of that idea that we're taking this parallel line, but then we're going to flip it. If I'm going to flip it, how could I flip 1 over 3? 3 over 1. So a perpendicular line, we have to flip it to make it be that 90 degree. We're going to do our slope of 3 over 1. Okay, so perpendicular. Oh my goodness. Cannot grab the color I'm trying to grab. Perpendicular. If we're going to do it from point M, that means we're going to go up 3 and to the right 1. Because we had to flip it. It goes from negative to positive, and then we flip it upside down. So from M, I'm going to go up 3, 1, 2, 3, and over 1. Okay, we draw that line through there. We go up 3 over 1, and then we can draw our line. And we know it's perpendicular, so what do we know about where they cross? It's 90 degrees. How can I show to my reader that that crosses at 90 degrees? Yeah, the little box. All right, so at the bottom of this, we're going to finish the rest of this finding from 2 points. We're going to finish tomorrow. So if you're a sophomore, we're going to finish this part, though, because this part's really important. So if you're a sophomore, go on that epic field trip. You're just going to miss that part of the notes tomorrow. Perpendicular lines have, what do we call it when it goes from positive to negative or negative to positive, when it flips like that? What's another word? Opposite. Does anyone remember what we call when fractions flip over? Starts with a re. Reciprocal. Good. Have opposite reciprocal slopes. And if you want to write next to reciprocal, that's like we flip it. That's going to be a really important part of this lesson. So tomorrow, if you're a sophomore going on that epic field trip, you'll miss our ordered pairs are always x, y. And we have 2 of them, so another x, y. All right, and to find out our slope, when we do our rise, we have to think about in our ordered pair which coordinate really represents the up and down motion. Do x's represent up and down or y's? Y's. So to find our distance, we subtract. We do y2 minus y1. Now, one way to think about this, that y2, I think about it as like the y from the second point. So the second point gets 2's. And this first point gets these x1 and y1. Now, depending on your teacher last year, some teachers use the word sub, so like y sub 2, y sub 1. I just say y2 and y1 because honestly I'm lazy. Just kidding, I'm efficient. But the reason we use the word sub, or some teachers in your future will say y sub 2, is because that little number in the corner is called a subscript. Okay? So y sub 2, it's saying it's a subscript. It's how you would type it into your computer, is using a subscript. But I just use y2 minus y1. We find that distance. That's our rise. That's our up and down. Now for our run, our left to right motion, that would be our x's. So x2 minus x1. So I kind of bringing back memories, y2 minus y1 over x2 minus x1.
I don't have one of those sheets.
All right, so as we find this, we're going to decide if these lines are parallel, perpendicular, or neither. So we have 2 lines. We have line P and line C. We don't have them drawn out for us. We have some points. Okay, and again, this is an example where it would probably be more work to graph it and find our rise and run than it would be just to do our y2 minus y1, our formula. Because if I was going to graph 10, 3, depending on the graph, I might be able to fit 10, 3 on the graph. But for 16, 11, I'm not going to be able to fit that on the graph, so I'd have to count by 2's, and then as we do our rise and our run, we'll have to keep in mind that we're counting by 2's instead of 1's. It turns into a whole thing. Okay, so as I finish this out, we're going to do our, start with our formula here, m equals. Now when I label my points, I always start by labeling how ordered pairs always go. What always comes first in an ordered pair? X. And then y. X, y. So I always start off by labeling x, y, x, y. Then we can decide which one do we want to be our 1's and which ones do we want to be our 2's. For the sake of just doing our first one, let's make our first point 1, x1 and y1. And then we'll make the second one x2 and y2. So in the numerator, in the top, we're going to start with our y2 minus y1. So which number represents my y2? 11 minus my y1, 3, over my x2, 16 minus my x1, 10. How are you feeling? Coming back to us a little bit?
Bless you.
Alright, so when we work through this, 11 minus 3, I like to just do it top and bottom. I don't like to type that whole thing into my calculator all at once. So what's 11 minus 3? 8. And 16 minus 10? 6. Alright, now, simplifying fractions, if that brings back some trauma in your life because you're like, fractions? What? I hate fractions. That's okay. We have this handy-dandy thing called Desmos and a calculator that will simplify it for us. 8 over 6. We have this little fraction button. We don't want slope as a decimal. We do want it a fraction. And we get 4 over 3. How did Desmos change 8 over 6 to 4 over 3? Good. Divided top and bottom by 2. So that would be a good way to simplify it if you knew how to do it on your own. So 4 over 3. Alright, so now we're going to find the slope of line C and decide if they are parallel. Parallel means that they have the same slopes. Or are they perpendicular, opposite, reciprocal? Or are they neither? Okay? So for line C, again, we're going to use our x1, y1. I'm going to go above this time. So I have x, y, x, y. Do you guys want it to keep the same where this is our 1s and these are our 2s, or do you want to switch it around this time? Just keep it the same. Okay, x1 and y1. We could switch it around as long as the 1s go in the same point and the 2s go in the same point. x2 and y2. Alright, so we start with y2, negative 11, minus our y1, which we have a negative 14. So I'm going to throw that in parentheses. That way it's just making sure that minus and that negative stay separate. Otherwise, sometimes it's like, oh, did my pencil just skip over a line? Was it supposed to be one big minus sign? Is it minus a negative? I don't know. All right, and then on the bottom, is it going to be 15 minus 11 or 11 minus 15? Dan lipped it, 11 minus 15. He didn't want to say it out loud, but he was right. Yeah, you were wording it. Were you wording this?
No.
It looked like it. Just take the credit. Say, yeah, I'm so smart, Miss Merrill. Yeah, exactly. All right, negative 11 minus negative 14. Again, it's okay to use a calculator. If you're using your phone calculator, you have to be really careful with those negatives and make sure you're using the right negatives versus what a minus is. Negative 11 minus negative 14, we get a positive 3. 11 minus 15, we get negative 4. Now with a negative, do we like negatives to stay on the bottom? No, negatives usually float to the top or to the front. So negative 3 over 4. Write that down. Negative 3 over 4. All right, so now as we look at these, are these the same? Are they opposite reciprocals or neither? First off, are they the same? Is 4/3 the same as negative 3/4? Nope, so not parallel. So remember, perpendicular. Opposite means we're going to go from positive to a negative, or vice versa. Negative to positive. One has to be positive, one's negative. Do we got that? One's positive, one's negative? Yep. Okay, then reciprocal. Remember, reciprocal means to flip. So if I have a fraction, the top is going to the bottom, and the bottom is going to go to the top. So did that happen here, that 4/3 switched to negative 3/4? Positive, negative, and did it flip?
Yeah.
Yep, so they're perpendicular. To write perpendicular, we use this upside down capital T marking. So we're going to say line P, and then is perpendicular. That's what we say when we see that upside down capital T. It's just showing that it's 90 degrees. So line P is perpendicular to line C. And if you're like, where the heck did we get that P and C from? That's what those lines were called originally. P, C. They were just random letters that they gave us. Okay, big thing down here is our parallel